have lots of instructors, lots of students, and lots of courses. So what the platform does is it provides an opportunity for instructors all around the world to create courses, post them online, so that learners anywhere in the world can consume these courses. When you come to the Udemy homepage, you'll find a page that looks something like this. Down near the bottom of this page, you see a course catalog. This is just 4 out of the over 100,000 courses on our platform. Whenever you click on a course, you'll come to a course landing page, which provides you the opportunity to dive in. And as a student, your experience is once you actually take the course, you can watch a video. As part of this video, you'll learn about the material. On the right-hand side, you see the overall kind of syllabus for the course. Sometimes you might see some assignments and other ways to engage with the material. So Udemy is a full multimedia platform. At the same time, Udemy is a two-sided marketplace, so we don't just cater to students, we also cater to the instructors who create the content. And so for instructors, of course, we have content creation tools, places for you to upload video, but at the same time, we also have kind of a number of tools to provide data and insights to help you understand what types of courses are worth creating, what types of courses have high demand. And so what you see here is an example from our Marketplace Insights tool that uses data from Udemy students who are searching on our website to tell what are Udemy students interested in. That can help you guide your content development. So overall, it gives you a sense of what the Udemy platform is all about. And so what I wanted to focus on today was to talk a bit about some of the technical challenges associated with developing the product and platform. And in particular, I'm going to talk about a particular area known as experimentation. Sometimes you hear about this as A/B testing. Okay. So just in a nutshell, experimentation. So this creature here, anybody know what animal that is?
Hippo.
It's a hippo, right? So I'll bet, in many companies, this is actually the creature that's in charge. It's a hippo, right? The reason why is the hippo really corresponds to the highest paid person's opinion. That's who makes the decisions. When you decide what product you want to launch, whether this feature should come out or not, what color should that button be, many times you default to the opinion of the highest ranking person in the room. And that's one way of making decisions in a company, but it's not always the best way of making decisions. So what are some of the problems associated with this hippo approach, right? So a couple things. One is, unfortunately, intuition-based decision-making by the hippo, it's often wrong. Many times we think we know what's best for customers, we think we know what's going to be most successful, but unfortunately our intuitions are misguided. And we'll talk a little bit more about this later during the talk. Another thing is, sometimes even when we have intuitions, our intuitions are generally imprecise. They're not clear enough to make clean decisions. So for example, we all know that for many consumer websites, it's important to have a fast website because a fast website makes it much more engaging for users. They can move easily from page to page, and that will probably make them more likely to stick around on the website, maybe more likely to purchase, so on and so forth. But do any of us really know how fast do you need a website to be? Does it really make sense if you shave off 0.1 seconds or not, right? Third thing here is, let's say you do have great intuition. Let's say you are Steve Jobs and you have the ability to design kind of the perfect product. The only problem is, still, even in that case, it's hard to scale decision making in an organization. Only you can make all these decisions, and so how do you get an entire company to build a wonderful product? So this is where A/B testing and experimentation comes in. So normally the way we think about this is you take all of your users, and maybe you divide your users into 2 groups. These groups hopefully look similar to each other in some way. Right? So the way that you make this happen is you apply some type of randomization procedure or matching procedure. And then for one of these groups, you'll expose one of these groups to what's called the treatment variant. This is like a version of your website that you've modified in some way. And then the other group you'll expose to the control variant. This is the unmodified version of your website. So now you have the treatment variant, the control variant, and after you've exposed users to these 2 variants, then over time you measure some metrics of interest. So your metrics could be anything from understanding how often do people click on a button, how often do people purchase, how long do people stay on our site, so on and so forth. Right? And by looking at the differences between the treatment group and the control group, then you can estimate a causal effect. So this is essentially, what is the impact that the treatment has relative to the control. So just to give you kind of an example of what A/B testing is like in practice, this is an example at Udemy. So on the top, you see our control variant, and on the bottom, you see a treatment variant. So, what's the difference between these two? Yeah, it's this best-selling badge, right? So the only change that we made to the site was for a subset of courses that were bestsellers. We added a best-selling badge. So the surprising thing is just adding this small badge, once you use the A/B testing platform, can actually dramatically increase people's confidence and willingness to purchase. And in fact, in the case of Udemy, this was actually one of our largest experiments, one of our largest wins, was something so simple as just adding a small badge. And that's, I think, one of the things that's also often very surprising about A/B testing. It's very difficult to predict where are the big wins going to come from. But this is actually one of those cases where we saw a very significant win early on. So now you have a sense of what experimentation is all about. And in particular, we talked about the most common form of experimentation, which is A/B testing. So this is great. It's easy now to develop any product, right? Well, not so much. So in practice, it turns out that despite the fact that experimentation is really powerful, we'll often run into lots of challenges. And so today, what I'm going to spend most of this talk on is talking with you about some of those challenges. Some of those challenges will be technical in nature. Some of those will actually be more social or cultural in nature. But both of them are actually equally important. So on the technical challenges side, I would group the technical challenges that you might face into a couple different areas. One is problems with experiment design, right? So, you might think like, oh, it's very easy to design an experiment because all you need to do is have a control group and then a treatment group. But as you'll see in just a sec, sometimes it's much more subtle than that. Another type of technical challenge that can come up is experiment execution. Even if you know exactly what you want to do, actually implementing the experiment itself can actually be very difficult and tricky. It may require a lot of investment in engineering infrastructure to make happen. And the third thing is experiment analysis. Even if you've managed to design a proper experiment, you've run it correctly, analyzing the results is often not straightforward for a number of different reasons. So let's explore each of these areas. So experiment design. So one challenge that comes up often in experiment design is in order to successfully run A/B tests, in order to run these experiments, you actually have to have enough users that you expose to the treatment variant and the control variant so that you can actually tell statistically what is the difference between the treatment and the control. So what I've shown here on the left side is a table that shows what is the minimum detectable effect size that you're trying to identify. And on the right column here, you see sample size. So in order to detect, say, a 10% difference in some metric. So for example, normally users on the site spend $1 per visit. You want to see if a change leads them to spend at least $1.10 per visit, right? So that's a 10% effect size. In order to do that, in your A/B test, you would need to have at least 14,000 people in each variant, right? And so what this means is, sometimes the sample size requirements are very high. And in fact, if you're looking for some of the very small effects, say like a 1% effect size, then you'll need millions of users in order to actually see that effect, right? So just to give a sense of how this plays out in practice and how that manifests in an actual business, right? So for Udemy, we actually have many different types of randomization units. We're not always randomizing people into the treatment and control groups. Sometimes we're thinking about sessions. So we're thinking about visitors who come to the site as determined by a web cookie, right? Other times we might be running, say, an SEO experiment. And in an SEO experiment, one of the challenges is what you have to randomize is no longer people, but you have to randomize web pages, because if you randomly treat, half of your web pages in one way, randomly treat another half of your web pages another way, then over time, the impact that you're trying to measure is whatever the search engines do as they index your page and then change the rankings of those pages. Finally, organizations. This is another one. So Udemy, I talked a bit about Udemy. I talked about the fact that we're a two-sided marketplace for instructors and students to come together. But actually, we also have another business model called Udemy for Business, where we'll actually take a lot of the content on our site and make it available for companies to use in their organizations to train employees. So when we're doing A/B testing with companies, often the unit of randomization is actually the company itself, the organization, right? And the reason for this is we want to ensure that all the employees within the organization have a consistent experience with each other. But when you're doing this, then the randomization unit is a number of organizations. And so, again, sample size becomes a significant challenge. So there are some things that you can do in order to improve this, but fundamentally, at the end of the day, the statistics mean you really do need a lot of data in order to make A/B testing. Another thing that can go wrong is sometimes you think about A/B testing, you think like, hey, I'm going to make a change to my site, and based on this change, I'll be able to measure some causal effect. But there are many cases where you actually can't make the change that you want. So for example, what if I wanted to understand what is the impact of watching a lecture video on future purchasing behavior? Well, the problem here is the treatment sort of means that I need to force somebody to watch a lecture video. So that means that I need to tie you down to your chair, make you watch a lecture video. And if I do that, I'm pretty sure you're not going to stay on the site at all, right? That's a pretty bad experience. So the question is, how do you actually do an experiment where the thing that you're wanting to measure, right, is an intervention that actually can't be forced on the user? So this is, again, a case where some clever experimental design might be able to help. So one thing you could consider doing is a type of study known as a randomized encouragement study, where instead of actually forcing a user to watch a lecture video, you apply a nudge on that user. You suggest to that user, hey, we think you should watch this lecture video, and you measure two different things simultaneously. First, you measure to what extent does the nudge affect the person's likelihood of watching the lecture video. And second, you measure to what extent does the nudge result in an increase in whatever metric that you care about, whether it's revenue or engagement, so on and so forth. If you compare those two things with each other, then you can actually back out from that under certain assumptions what the effect of lecture or video watching is on the metric of interest. And this is known as an instrumental variable study. So for those of you in economics, you may have seen some of this kind of design as well. So again, this is a situation where you have to carefully craft the study in order to get the result that you want. Another challenge that can come up technically with experimental design is sometimes you might not actually want to experiment. So for example, at Udemy, we are a two-sided marketplace. We work with a lot of different instructors to provide content on our site. And the way that we incentivize instructors to participate on our site is whenever students come and buy courses, we'll actually split the revenue that comes in with the instructor. But one thing that may be the case is over time, right now we have some particular revenue share with our instructors. So some percentage of the money that comes in for each purchase goes to Udemy, some percentage of that money goes to the instructor. What would happen if we started changing those percentages? Can we measure the impact of that? Well, one problem would be you probably don't want to A/B test this, because then what that would mean is you're changing the revenue share for some instructors and not changing the revenue share for other instructors, and that's a very unfair situation, right? So in this case, maybe you can't even really run the A/B test because nobody's really actually willing to randomize. But there are many other methods that you can use. So Bayesian structural time series is an approach where effectively what you do is you look at what your revenues were like before, you look at what your revenues are like afterwards, after you make a change. And then in order to get a control group, what you do is you use a forecast based on previous trends to understand what revenue would have been like had you not made a change. So that way you have a treatment group and what is effectively a synthetic control group. And this provides some basis for causal estimation. All right? So yet another case where running an A/B test is a little bit hard, but you have to think about it very carefully. So let's say that you've appropriately designed an experiment. What challenges can come up in executing on experiments? So one challenge is, well, we've just actually got a lot of scale. So at Udemy today, we've got over 40 million students on our platform. So running an A/B test, even if you have a perfectly designed A/B test, is a non-trivial challenge. We've got to support quite a lot of load. Another thing is, you may not just be running an A/B test on your web platform. Sometimes you might need to support multiple clients. So for example, let's say you wanted to A/B test emails in addition to, maybe you want to A/B test some email promotion that gets sent out at midnight all around the world, right? So the challenge here is that when you're trying to A/B test email, because there's a big bulk email send, then you'll need to figure out some way to ensure that whatever service that you have that's running experimentation doesn't go down due to the load, since all the traffic is going to come at one time, right? So they're very different usage patterns. Another thing that you need to worry about with A/B testing as well is, like, let's say that you start running an A/B test, and within 10-15 minutes it becomes obvious that your attempt at experimentation is not working well. In particular, maybe there's a bug in your treatment variant. Maybe there was something that you did which led to a very unexpected user behavior. How can you detect that quickly enough and then address it? So in order to do all these things, you really need to build a strong experimentation service that is able to auto-scale, that has near real-time monitoring, and is able to detect problems early. So these are non-trivial challenges that we have to face. Another challenge that can come up is, I painted this picture of this perfect A/B test, right, where you're able to split the users into two groups, the treatment group and the control group. But reality is not so much like that all the time. So for example, let's say a user comes to our site, and the way that we bucket the user is we bucket them based on some type of cookie, so a web cookie or something like that. So a user comes in, and they see variant A, and then after some amount of time, based on variant A, they decide to purchase a course on our site. Right? So this is simple enough. We know that this user was bucketed to the A variant of the experiment. But in other situations, it may be possible that the user decides to leave the site and come back the next day. And when they come back the next day, maybe the cookie has changed, maybe the user has cleared all the cookies on their browser, maybe they've decided to come back to Udemy on a different device, a mobile device instead of web. And so now that user sees variant B in the experiment. Then later they see variant A again, and variant B, and then finally this user makes a purchase. All right? So now the challenge is, if we look at this data, what variant actually gets credit for the purchase? Is it variant A? Variant B? Some combination of both? This is not entirely clear at all, right? So this is another case where, ideally, if we had been able to assign the user to one particular variant all throughout the experience, then we would have a very clean A/B test. But in practice, this is not always possible. And in fact, because many of the experiments that we run at Udemy involve bucketing users who have not yet logged into our website, we have no choice except to use cookies for bucketing. The consequence of this is we run into this type of situation all the time, and that will muddy many of the treatment effects that we're able to measure. So are there ways around this? Possibly, but these are things that we have to work on. So one thing that you might consider doing is randomizing not by a cookie ID, but using geolocation or maybe IP address or things like that. But even then, these have some problems and trade-offs as well. So overall, you don't always get everything that you want in experimentation. One final thing I'll point out is mobile. Mobile presents some problems all on its own. So users who use mobile devices, sometimes they're online, sometimes they're offline. So what happens if a user comes to the mobile app while the mobile app is offline and then enters an experiment. Now this is a bit of a problem because you need to be able to perform the bucketing. You need to assign the user to a particular variant, but you're no longer connected to the net. You don't have the ability to access an online server. How do you ensure that bucketing can happen when the user is offline? So that's just another thing that you have to take care of. There are some relatively straightforward solutions to it, but it's something that can go wrong if you're not prepared. All right, so that's execution. Then finally, let me talk here a bit about experiment analysis, interpreting the results of experiments. A bunch of things that can go wrong here as well. So let's say what you're doing is you're bucketing different cookies that come to the site, different users who visited Udemy. Sometimes one of the things that we'll see is we'll actually see a lot of bot traffic. We'll see web crawlers come to the site, look at different pages, maybe they'll click on this and that. And if we're running an experiment where we're trying to measure changes in, say, click-through rate, for example, the presence of these bots, these web spiders, can actually affect the results quite significantly. So for instance, in the picture that I've shown here, we got kind of unlucky, and one of these bots happens to be in the A variant, very consistently, has decided to click on a whole bunch of pages in the A variant. So we would look at these results and we'd say like, oh, well, the click-through rate for variant A is higher. But that actually doesn't really represent human behavior on the site. That's just the artifact of not cleaning out the bot traffic, right? Similar sort of thing can happen. Another way to skew results is if you have users who are power users who end up actually behaving very, very differently from other users on our site. So for example, let's say that you're interested in trying to run an A/B test where your measurement is the revenue per visitor who comes to the site. If you have some users who actually spend a lot of money, they can actually throw off your results considerably. So again, in this situation, variant A seems like it makes more revenue per user, but that's simply because there's one user that happened to spend a lot of money. So what can you do in order to make your A/B testing system more robust to these types of problems? You'll need to think about things like bot filtering, metric capping, filtering out outliers, but you also need to do these in ways that are not fundamentally biased and that lead to inaccurate inferences around the causal effects. Another thing that can happen that's weird, and we've actually encountered this one as well at Udemy, is sometimes you think like, okay, well, I'm running my experiment, and if I run my experiment longer, then eventually I'll have enough users in my experiment, and I will actually be able to see some statistical significance in the results. But there are some cases where what you find is that the longer you run an experiment, you don't actually see any more conclusive results at all. And in fact, all estimates of effect size tend to kind of stay the same in terms of their uncertainty over time. So what I've shown here in this diagram is the expectation that you might have is that the more time you run an experiment, the more data you collect, and the more certain you are of an effect size. But in reality, in some cases, you'll actually see that the effect size doesn't get any more certain as time goes on. So how does that happen, right? So one way that can happen is if the metric that you're measuring is an unbounded metric that grows with the amount of time that the user is in an experiment, then as the experiment goes further and further and further in time, the metric continues to increase in magnitude. And so the variance of the metric also increases in magnitude. And as a consequence of that, your effect size that you're trying to estimate never really gets much more confident over time. So there are ways to address this again by changing the metrics that you're using, thinking about your problems in different ways, or maybe like bounding the amount of time that any user is in the experiment, for example. But nonetheless, this is a problem that can arise in practice. Final thing I'll point out is, we talked about simple A/B tests, but there are cases where you think you might be able to do an A/B test, but it's actually much harder than that. So for example, one problem that could occur is, let's say that you wanted to do an A/B test around a feature on Udemy that allows users to interact with each other, right? So the challenge here is if you have some users who are in the treatment variant and some users who are in the control variant. In the treatment variant, you might push those users to participate in some discussion forum, but because those users participate in the discussion forum, suddenly the discussion forum looks much more attractive to all users in the course. And as a consequence, now the control users are also affected. So there are some spillovers from the treatment group to the control group. And this actually invalidates a lot of the analyses that you might typically use when running an A/B test. Another place where this can arise is, we talked about the fact that Udemy is a two-sided marketplace. And in a two-sided marketplace, we have connections between users and instructors. But there may be cases where, because of this two-sided marketplace, whenever one user there may be cases where there are interactions between individuals on one side of the marketplace with each other. So for example, imagine someday that Udemy goes into like a tutoring marketplace. We decide to provide a tutoring service where we connect students with expert tutors. So if one student gets matched with a particular tutor, then perhaps that tutor is now no longer available for other students in the marketplace. And so again, an intervention that happens to one student that encourages that student to match up with this one particular tutor now has a side effect on other students, right? So these types of side effects lead to something called interference. And so in order to do proper causal inference, you actually have to change the methods that you use to be able to deal with this interference. So it makes things much more complicated, okay? So that was just kind of a brief tour of some of the things that can go wrong from a technical perspective when running A/B tests. They're not always straightforward, but with enough patience and hiring folks who are strong enough in statistics, then eventually you can kind of figure these things out. Okay? But the technical problems are only one side of the issue. So there's also cultural challenges that you might face when doing experiments. So cultural challenges I'll bucket into two areas. So one is, how do we think about applying experimentation A/B testing in a company? And second, what is the discipline that's necessary for running experiments? How should these experiments actually be conducted? So let's start with experiment applications. So one challenge here is that when people think experimentation and A/B testing, it's very easy to get into this mindset that A/B testing is about incrementalism. It's about making small improvements over time to a product so that product gets better and better and better. And in many ways, that's actually true. Incrementalism is not necessarily a bad thing. It allows you to iterate continuously and improve your product until it can become great. But at the same time, there may be cases where you want to take bigger leaps, right? So a cartoon on the left here shows kind of a case of, hey, we have this amazing painting that the person has produced, and the folks on the right are saying, let's A/B test our way to improve this painting. That seems like a pretty bad outcome. So what can we do? If you're in a company, you're thinking about A/B testing, don't just think about the small micro optimizations that you could make. Think also about testing bigger interventions. Think about ways that you can fundamentally change the product and use A/B testing as a way of measuring the impact of those changes, not just to apply it. Another thing that can also come up is that, aside from incrementalism, many times A/B testing is associated with short-term metrics, such as click-through rate, or say like short-term revenue, right? And the challenge with these short-term metrics is once you measure them, it's very easy to get stuck in the mindset of optimizing for the short-term metrics. That can ultimately be harmful for a company. So one thing that you could do with A/B testing to improve this situation is to think about what are ways that you can find metrics that you want to optimize for that are proxies for longer-term outcomes, right? So for example, instead of building a company that focuses itself purely on optimizing revenue, maybe you need to optimize a combination of revenue plus user engagement, right? So bringing different aspects of what is valuable to users into the overall evaluation criteria that you use for an experiment is important to ensure that you're not just optimizing to a local minimum. Another thing that can come up is, A/B testing is also nerve-wracking in practice. So what you're doing is you're putting up a lot at stake. You're effectively exposing users to different variants, and you're not totally sure how these variants will work out. And so this can actually be very uncomfortable, especially in companies. So imagine you have a company where performance goes up and down over time. Sometimes everything's great, revenue's super strong, other times revenue's a little bit weak, right? So a thing that can happen is, executives may sometimes think like at times, when revenue is doing really well, hey, don't touch anything. We don't want to mess anything up. Don't run your A/B test. But then when things aren't going so well and it feels like you need to do something in order to improve the situation, maybe that's the time to take more risk. Part of the problem with this type of mindset is that if you have this mindset, then effectively you're only running experiments, you're only trying to understand what's going on in your business when things aren't working well, and you're losing kind of a big opportunity when things are going well to do more of what actually works, right? And so the thing I'll point out here is that, unfortunately, a strategy that's focused on avoiding all short-term risks that may be caused by something like A/B testing actually can be risky in the long term. Maybe one way to think about this is in terms of investing, for instance. There are strategies focused on investing in stocks, strategies focused on investing in bonds. When you invest in stocks, there's a lot of volatility, but that doesn't necessarily mean that the right thing to do is to always put all of your money in bonds just because it feels a little bit safer. Because in the long run, you may end up suffering from missing out on a much better expected gain elsewhere. Another thing I'll point out is that many times, A/B testing, we presented A/B testing as a bit of a science, right? But the reality is that many times there's a lot of judgment calls that need to be made. So for instance, you run an A/B test, you see that in this A/B test, perhaps the treatment that you introduce improves one metric, hurts another metric. So this is a situation where you will need to make some type of judgment, and that's a valid type of judgment call that you do need to make. But other times, there may be other judgments that are made in a company where you look at a situation and you think, oh, I'm going to change this button color and I don't really need to A/B test this. It'll be totally fine. That shouldn't make a difference, and I'll just go and roll out this change, right? So the question of whether to run an A/B test, do you spend the time to do that, or do you not test, do you just ship a feature that you ultimately want to ship? This can actually be a slippery slope, right? If you decide not to test things. The problem is human intuition, as I said before, is often very unreliable. And in fact, there are a number of different studies from major companies like Microsoft, Google, Slack, Netflix, etc., that show that, in fact, humans are pretty bad at predicting the outcomes of A/B tests. Out of all the A/B tests run at Microsoft, typically the PM has an idea going in of which variant is going to win, and the PM is right about a third of the time. At Netflix, it's even worse. Maybe 10% of the experiments that are run at Netflix actually succeed. So this tells you that maybe as humans we think we have an idea as to how we should be designing our products, and that may lead us to skip out on testing at times. But the reality is letting the data speak for themselves can often be very important. Other thing I'll talk about here is experiment discipline. How should experiments be conducted? So one common thing that can occur, an anti-pattern in A/B testing, is actually to run an A/B test, to start splitting users into a treatment group and control group. And then once you're done, once you've actually finished running the A/B test, then you look at the results and then you cherry pick whichever set of results looks most appealing to justify launching a new product feature. So the cartoon on the left, you see the guy has shot a whole bunch of holes in this board, and then now that he knows where all the holes are, now he's drawing all the bullseyes, right? So that's great. He'll never miss this way. The only problem is he's not really actually getting an unbiased measure of true causal effects. So when can this type of problem happen? Couple situations. So one situation is, let's say that you're measuring a large number of metrics in your A/B test to begin with, and then you decide after the fact which metrics you think are most important to justify a product decision. That's one way that you might end up in this situation. Another way is maybe you decide to segment the results of your A/B test post hoc. You've run your A/B test, and then now you've identified a small group of users within your overall population for whom you think this change has a positive effect. And now you're going to say, like, okay, well, I tested everybody but it really works well for users who come from Ankara specifically. So we're going to release this product feature just to Ankara, right? So segmenting experimental results post hoc can also lead to problems where you're just cherry picking the results that you like at the end. So in order to prevent this, you really have to have a clear sense of, what is the analysis that you want to do beforehand? What are the actions that you're going to take so that you can make unbiased decisions at the end, right? So in the scientific literature, this is known as harking, or hypothesizing after the results are known. You want to avoid that at all costs. Final thing I'll mention here is that besides analysis, actually another common thing that can come up in A/B testing is it's really important to think about how you report the results of A/B tests as well. Because depending upon how you report the results, the reporting can actually lead to misinformation in the company about what actually works and what doesn't work. So for instance, on the left, I've shown a situation where you've run an A/B test, and the impact that you measure seems to be somewhere between -10% and plus 30% in some metric of interest, right? So, if I were to ballpark it, then somewhere in the middle of that distribution is around plus 10%. That's halfway between -10% and plus 30%. So what are the different ways that you could describe what's going on here? You could say the treatment resulted in a plus 10%, i.e. -10% to 30% increase to revenue. That's one way of phrasing things, and I think that's reasonably fair, right? You could also say the treatment resulted in a plus 10% increase in revenue. So now the issue is you haven't really qualified how certain is that 10%, And in fact, if you look at that graph, you might realize, actually, we're not so certain it's really a 10% increase to revenue. It seems like there's a 1 in 3 probability that actually this treatment variant will decrease revenue, right? So that's a problem. One thing you could say is the treatment did not significantly increase revenue. That's, in some sense, accurate from a statistical hypothesis testing perspective, but I'm not sure that tells you a lot of information about what's going on. The last statement here is particularly obnoxious, but I've actually seen before. I've seen PMs get very excited about the product that they want to launch, and they'll look at this range -10% to 30%, and they'll say, well, the treatment resulted in as much as a 30% increase to revenue. That's probably not a fair characterization of what's going on here, right? So it's important to think a bit about, how do you want experimental results to be reported within your company, and can you standardize that in a way that information from A/B tests can be communicated accurately. One more thing here. I'll also mention that when you run A/B tests, the results of an A/B test actually often take a while to see, right? So you initially launch the test. When you initially launch the test, users who see a new feature on the site will often click on that feature. They'll think, oh, what's this? I'm interested to see what this is all about. And so up front in the first several days, you might see what's called a novelty effect, where people are engaging a little bit more because they're experiencing something new. After that, though, you still might be in a phase where your sample sizes are not very high, and so as a result, your metric might not be very stable. Even though you estimated the impact to be positive initially, the next day it might be negative, it might bounce back and forth for a while, that's statistical noise. Eventually you get to some measure of the short-term effect, what is the effect after a couple of weeks. But what may be more important to you as a business is to understand what is the long-term consequence of this treatment on your user, right? So there are many phases of how metrics can evolve, and one of the consequences to this is it can actually be very tempting to just peek at your results all along the way. For those of you who are statisticians, you know that peaking can actually lead to inflation of type 1 error rates. So the thing that you really need to do here is you need to think about, if you want to be able to navigate situations where it looks like your effect sizes are fluctuating over time, but you want to make reliable calls, how can you codify that into some type of repeatable process that stakeholders in the company can use? One best practice I've seen is to create what's known as an experimentation review meeting, a meeting that occurs on a weekly or bi-weekly basis, where the purpose of the meeting is to educate people in the company around how does A/B testing work, what are valid ways to look at results. And another purpose of that meeting is to ensure accurate interpretation of data that come from experiments. So non-trivial thing to deal with. So that's just a whirlwind tour of some of the different cultural challenges that can come up. And the final thing I'll close with is I'll talk a little bit about what we're doing at Udemy around experimentation. So a little bit of our history is in the early days, around like say 2015 or so, we started building a lot of our internal A/B testing platforms. We did investigate some third-party frameworks, but decided to go with something internal. And then we had two different groups actually within the company. We had a team at the time called the analytics team, as well as the data science team, that independently built different A/B testing analysis dashboards that were used at Udemy. And more recently, in 2018, we unified a lot of these analysis methods into something that we call the Bayesian or probabilistic A/B testing framework. And now what we're doing is we're, again, kind of like revamping the way that we're thinking about A/B testing to deal with some of the problems that I mentioned earlier, as well as changing a lot of our underlying infrastructure around bucketing. We're moving from an A/B testing platform that was really baked into the Django monolith that we were supporting before to an independent experimentation bucketing service. And so overall, the vision that we have is that we want to build this experimentation platform that includes elements of backend infrastructure, different client libraries, different tools and interfaces that can be used by analysts, product managers, engineers, and also figuring out how to develop the right culture and processes within the company so that we can make high-quality, data-driven decisions. So, what's the purpose of all this? There are multiple things. One is decision-making, and we've talked a bit about how A/B testing can really inform the decisions that are made within a company. Another thing that we're also thinking a bit about is the possibility of A/B testing over time turning into a tool for personalization. So for instance, imagine when you run an A/B test, instead of deciding whether the treatment group or the control group is actually better and then just rolling out one of those two variants. Instead, what you do is you build machine learning models that allow you to predict for each individual user on your website whether the treatment or the control will be better. And once you have those predictions, then you personalize the treatment that you show to the user based on that predictive model. This is kind of a stepping stone from A/B testing and experimentation to personalization. So this is where we're going with some of these systems that we're wanting to build. But do we have all these in place right now? We don't. So I'll end with this slide. We are hiring. So thanks very much.
Any questions? Any questions? Comments? I can have one. We have companies here who are startups like game developers or some network startups. They're just maybe at the very beginning of the way. But first question is when they should start worrying about experimentation and about their maybe user size or and this. The second question is what will be your first advices, first thing to think about experimentation for those companies? Thank you.
Yeah. So one thing that people often worry about with A/B testing, I mentioned the sample size issue, is people often think, oh, because of sample sizes, if I'm not running a really large consumer internet company, then it doesn't make sense to do A/B testing. But that's actually not really true. And one of the reasons for that is at the early stage of a company, when a company is still relatively small, even though there are not a lot of users, the types of effects that you might be most interested in tend to be very large, right? Otherwise, it's not really worth your time. So if you have a small startup, you probably shouldn't be hunting for 1% revenue wins or anything like that. You might really be wanting things that are like 50% revenue wins, 20% revenue wins, because those actually fundamentally change your business. So A/B testing can be useful in that space. Over time, as your product gets more and more mature, you get more and more users, and then it makes more and more sense to hunt for kind of some of the smaller wins. So what I would say is, if you're a game developer, if you're starting out small, nonetheless, A/B testing actually can be useful even at an early stage. As far as general advice that I have, I think the biggest piece of advice that I think is important that many people often overlook is really just the idea of designing your experiments ahead of time. The most tempting thing to do is just to run the A/B test because we're all developers. We think, oh great, let's just develop the thing. Once we have it running, we'll figure it out later, right? We're collecting all the data. We'll figure it out later. But the truth is that unless you take the time to really think about, hey, is it really worth running this experiment? If I run this experiment, how am I going to make a decision? You'll end up with really bad analyses, and you'll end up making bad decisions for the business. All right. Other questions? Yes.
In an online game setup, is it even possible to do A/B testing? A really short question.
Sure. In an online game setup, it is sometimes possible to do A/B testing. So in fact, many companies, especially in companies like Zynga, for example, a lot of what they do is A/B testing in order to optimize user engagement. Now, the truth is, I think in an online game setup, what we see in a lot of online game companies is online game companies may sometimes tend to overemphasize A/B testing, and that can lead to micro optimization or focus on like short-term metrics like revenue. But in general, yes, A/B testing is highly applicable in that setting because what you can do is try out different interactions with users. Maybe some users you offer a new feature, such as a new skin or something like that, or a new in-game mechanic, and then you see what does that do to user retention, and what does that do to revenue over time. Other questions?
Any questions anymore? Okay, I have one then. It's a hypothetical question, but think of me like I'm a last year statistics student, okay? And I want to specialize in experimentation. What would you suggest to me?
Oh, as a last year student in experimentation, well, first you should apply to Udemy. We're certainly in need of folks who can think about causal inference. But I think another thing to think about is like beyond the math, right? It is really important to spend some time in companies and organizations and realize that experimentation is far more than just the technical aspect. A lot of it is really about developing the right internal culture so that other people who are not statisticians really buy into the methodology and are able to make decisions correctly. This aspect, I would say, is probably maybe often harder than solving a lot of the technical problems associated with experimentation.
Thank you, Tom.
All right.
I guess I had enough questions to make some time to get the pizzas ready. So, here is the program now. We will have like 30-40 minutes of break. Yeah, we will have delicious pizzas. So please go ahead, meet new people, and do networking as your best.